First, thank you for that kind introduction, and I want to thank the committee for this conference, for inviting me, and in particular Professor Molin for providing the opportunity to ask. And it's just been a wonderful time here in Brazil so far. I need to commend that people like Professor Molin are pioneers, visionaries, and I know he's done some work in the U.S. and travels a lot. And as far as I'm concerned, in Brazil, you're very lucky to have someone like that, along with other good scientists working in this area, because it's, in my opinion, a very necessary topic to develop technology. And now in the U.S., we talk a lot about data and how we're going to generate information from data. So I'm going to step through some of the ideas that I have for how precision ag will support and push yields. We talked about the population, but how are we going to increase yield with using less? I mean, that is what we are tasked, or what I would say, that is our requirement today, is to do more with less. And to me, it's the technology and the data that's going to be a key piece. Based on my data, I will make the comment today that we talk about increasing yield globally by 50 to 70%. 30% of that increase, 30% of that increase will be a direct result of using precision ag technology or management strategies that we change on farm to better manage our crops to meet that yield goal. So 30% of the increase globally, to me, will be tied to precision agriculture somehow. So if we were in the U.S. today, and I'm not going to talk about all these, we would have 4 topics on the program of an event like this. We would talk about data and analytic services, or big data. This is a ongoing topic. It gets very heated and a lot of debates, but it's probably the largest discussion today in the U.S. Wireless technology. We're spending nearly $1 billion to put wireless technology on equipment and building the ability, cloud services, to get that data in a location to process it. So wireless or telematics is a big topic. Planter technology, and I will talk as examples today about planter technology. We're spending a lot of time on making sure at the front of the season, primarily corn and now soybeans, that we're getting the seed placed and equipment is running at high performance today. And then finally, we've already discussed this here, is UAVs or UASs. A lot of discussion, as we had earlier this week on Monday, about UAVs. As a university and as a government, we were using them to continue to conduct research, but farmers cannot fly UAVs like here. But we continue to push, and I will show you some examples and talk about that later in my presentation about UAVs. I'm personally very excited about UAVs because when I look at the population, okay, in the U.S. only 2% or less are actually farmers, and 98% of the population is telling farmers how they need to farm, primarily about how to use fertilizers. And when I look at UAVs and the ability to collect data, timely data, to fine-tune fertilizer applications, to me that's a wonderful tool that we can show the public that technology and how we're being good managers of fertilizers. So with that, we're going to talk a little bit through this. I want to thank Paula, who's doing hopefully an excellent job of translating, but we've gone through this. But Dr. Stafford threw out 8 challenges, and I thought these were excellent. So I wanted to bring this back. And we started Monday morning talking about these 8 challenges. I think these are ones that we need as at least researchers and even farmers or consultants need to take upon ourselves to have solutions for each one of these 8 challenges. The one thing that we left off of that list, at least in the U.S. and as I travel in Europe, Australia, and New Zealand, the one big challenge, and I think that same challenge is here for farmers, is time. They do not have the time to invest and spend with things like crop sensors. How do I take a crop sensor, integrate or use it on my farm successfully to manage things like nitrogen? That takes time. And so a lot of our farmers in the U.S. have gotten used to guidance, automatic section control. Okay, those are what we call turnkey systems. They just work. But when it gets down to doing time, we talk about variable rate, in particular the time it takes to analyze and develop prescription maps. That becomes a very big challenge for most of our farmers in the United States. My second stat that I will tell you, in my opinion, in the United States, 95% of our farmers will rely on another company to manage their data. Okay, I'll say that another way. 95% of the U.S. farmers will rely on someone to generate prescription maps and manage their data. There will always be the 5% that has either someone on farm that can use the software and generate prescriptions, but 95% will rely on someone else to manage that data. And therefore, I've showed you number 1 on the list, data analytics, a big topic. That's why it's so of interest, not only in the ag industry, but we see a lot of investment. We've had over $1 billion invested in the U.S. for data analytics, big data, okay? Most of that money, I will tell you today, is not from the ag sector, not agriculture. Those are companies that are coming from England, investors, coming from New York City that are investors. Companies like Google, Amazon are paying to manage ag or farm data. So I'm going to talk a little bit about U.S. trends, so hopefully you understand some of my later comments. Right on top, there's 2 things about technology. I told you 30% of the growth and yield will come from precision ag. There's 2 things. All right, I'll bring up GMO or seed technology. Definitely has had a positive impact in the United States about growing yield. But we see a lot of investment in precision ag technology that we've been talking about here. Over 60%, okay, over 60% of the farmers in the U.S. use precision ag today. Some of that's technology, sometimes that's a consultant who comes and helps them with their grid or zone sample, okay? But heavy investment in technology. 100% of the high horsepower tractors, harvesters, and sprayers in the U.S. come with technology on them today. That's where we're at. Guidance, RTK guidance is essentially what we would call air conditioning. It's already on the machine. Now I might have to pay to use it, but it's on the machine. Okay, just like a steering wheel for the seat that you sit under, it's already integrated into the machine. I already mentioned ag data management. I want to say 2 things about it. It's the #1 topic in the U.S., okay, for 2 reasons. Number 1, crop insurance. The crop insurance companies are requiring data to report acres and to report yield. and they are giving discounts if a farmer participates in precision agriculture. And the second thing that I'll talk about is sustainability. The sustainability movement in the U.S. This is being led by Walmart, which is a superstore, okay, that sells food, clothes. They're one of the largest, what we call retail stores. Because of the public's demand about how farmers are managing fertilizers and growing crops, they're beginning to put in place a structure for farmers. If a farmer wants to sell grain, such as corn, to a food processor that makes a food that ends up at Walmart, they have to prove, that farmer has to prove that they're doing it in a sustainable way. Walmart wants two things from that farmer. How much fertilizer have they used, and what is the yield of that crop? So corn, for example, if I use 1 unit of nitrogen to grow 1 bushel of corn, that is sustainable, because in the U.S. we understand that we need 1 pound or 1 unit of nitrogen to grow 1 bushel of corn. If I use two units of nitrogen for one, then I'm not being sustainable, and there's a good chance that they will not purchase. The second thing is interesting that I have not heard talked about at this conference is the carbon footprint of the farm. You have to document what your carbon footprint is and report that. And right now, the only way that that's going to be reported is through precision ag data. Okay, and so we talk a lot about what goes on up here at the farm itself. How are we going to use yield maps? But in reality, sustainability will be the main driver of data in the United States to prove that I'm being sustainable and I can sell product into supermarkets. Our food processing companies, so people that take raw materials and make food, are going to require the same data in the U.S. And that is going on today. So with that, I'm going to talk about what I say is the 3 buckets of focus in research and 3 buckets of focus at the farm today. Number 1 is efficient and accurate machinery operation. Okay, how am I managing that machinery? And is that machinery performing at a peak level? Okay, the best it can perform. Okay. The second thing, and I'll try and explain this, is what we call sound input stewardship. So I talk about the seed. Okay. Our farmers pay somewhere on the order about $120 to $150 an acre. Okay, $120 to $150 an acre just to have a seed to plant. It does not include any of the planting costs or management around that seed. That's a pretty high number today. Of that, let's say $125, $100 of that is a technology fee. $25 is actually for the seed itself. Okay? So it is very important that I manage that seed. I place it as I expect. I manage around it. And the other piece in there is the sustainability piece. Is that seed being managed in a sustainable way that I can prove to the public? And the third thing, am I being environmentally friendly? So we talk about agrochemicals or pesticides, we talk about fertilizers. I've got to be as efficient as possible to make sure that I'm not having an environmental impact. And that all gets wrapped into what we call sound input stewardship. And today, we're taking the big data idea and trying to wrap or use it to better manage these 2 pieces. So when you talk to someone like me about what I'm doing in research, this is what I'm thinking about constantly. How do I take data to build information to better manage inputs and to better manage my equipment? I want to give some examples of some equipment. why we're focused on that, but at the same time some concerns. So currently farmers are very interested in timeliness of application. So what is the field capacity? Last 2 years we've had very wet springs, and we've had on the order of about 7 days to plant corn in most areas of the country. That's a very narrow window, very short time. So we're very interested in field capacity. And again, very interested in efficient use of fertilizer and seed. I think if you talk to most of our U.S. farmers, they recognize that in the future they have to use less fertilizer and less water to grow more. Okay, and so that's what we're pushing. The other thing is the environmental aspect. I'll tell you in the state of Ohio that all farmers, every farmer that applies an inorganic fertilizer, so a potash, has to be certified by law today to apply it. That's a new regulation. So if I'm a farmer in the state of Ohio and plan to apply nitrogen, urea, okay, or UAN, I have to be certified. I have to go to training today by law in order for me to be legal to apply that. That is all around this environmental component right here. So I'm going to talk just momentarily, just briefly about data, and then we're going to get to talking about some equipment. We see 3 data streams coming off of a field. We see production data, where a lot of you would call agronomy data, yield maps, as applied maps. We see machine data, so CAN, okay, ISO bus standard or ISO 11783 was mentioned. We're collecting that data and utilizing it to manage the machine. What's the health of that machine? So has it been serviced? Okay, is there some issue on that machine? So we're constantly looking at that. So that machine data. If you talk to the John Deere, okay, and talk about their farm site product, they're going to have production data and then their machine data. So JD Link would be machine data, then you could add the production data on as data that can flow off of the machine into a cloud. The other thing, and I'll come back late in my presentation to show, is capturing the perceptions or what the operator is saying or thinking during the process. So things like Google Glass. Okay, there's a third data stream. And of course, if you come to the U.S., we see all the companies talking about climate and weather, how much rain's been applied to the field. Okay, you document that. And then ultimately, if you're using irrigation, what's the soil moisture? What's that irrigation, turning on and off the irrigation? Again, all this currently is flowing to a cloud that we can access, and that's where we're at. All this is going to a cloud. So, I'm going to give you an example. So today in the U.S., I can take a single corn plant, one corn plant, and essentially tie or associate a ½ kilobyte of data to that plant per year. Okay, so I can generate a ½ kilobyte per plant corn per year. I'm just trying to get you to think here. If I've got about a 911 hectares, I can keep it on my 2 gig hard drive. Okay? But again, today we're trying to get rid of the hard drive, or of the thumb drive, or pin drive. I'm trying to get rid of that. But I can store 911 hectares on this thumb drive today. Thinking about storage, just as an example, storage is essentially free. Okay, if you look at my numbers up there, Amazon, most companies are buying storage from Amazon. If you go online, it's about 36 cents a gigabyte per year. Basically, for 10 years of data on a 2,000 hectare farm, I'm only spending $300 US a year to store that data. That's pretty cheap. Very cheap, okay? The problem is, it's not the storage that's concerned in the US, it's the analytical cost. How much is the service to process the data, okay? Now, we're in the process in the US, and you'll see some things later on, but trying to tie additional attributes, okay, to each corn plant. So the leaf structure, the stalk diameter, okay, what's going on below the ground, the root mass. Then I add in soil, moisture, the weather or rain, irrigation, and maybe crop health, even start to add that in. And I get to about 0.85 kilobytes per plant per year. You're shaking, you're probably going, John, what are you talking about? This is where we're at in the US. We're talking today from a research and even company perspective about a per plant management scheme, okay? So 0.85 kilograms. So if I take that over, I can basically get 64 megabytes per hectare per year for corn. Again, that's just average. We're talking big data because when you say that we grow over 90 million acres of corn in the US, that's quite a bit of data if we were going to store all the data. Now processing that becomes the big data aspect. So the question though, and I thought Dr. Stafford did an excellent job of throwing this out, how do I take that data though, okay, and start to aggregate it? How do I bring everyone's data together so everyone can learn from it? And that's the hurdle we have. But how, really the question is, how can I change my farm management to maximize profit? And so that's where as a university we're trying to steer companies to focus on the farmer in this very question with all the data. And we'll see what happens over the next 5 to 10 years. So let's turn our attention a little bit. So we talked a little bit about data, how much data from a precision ag perspective we're generating. Talk about machinery. And of course, in the US, we love large or big machinery. This is the John Deere DB120 corn planter. I'm not sure you have it here in Brazil. You do, good. Okay, this is my friend. These folks live in Nebraska. Carrie and Angela Knuth. I want you to listen to this. Carrie and Angela Knuth, I do some work with, have a DB120. It's 48 rows. It's nearly 37 meters wide, and they only farm 2,700 acres. Think about that. Going back to field capacity. 2,700 acres, and they own this machine right here. A couple things I want to point out about this machine. We have a weight issue on this planter. We load the seed and possibly some starter fertilizer right here, so all the weight is at the center of the machine. You got 15 meters on each side. You tell it you want to plant at about 3 centimeters, well, 5 centimeters. How do you keep that outside engaged in the ground? Precision ag technology. Okay, basically, if you've listened, that the reason we have active downforce or downforce on each row from John Deere is because of this machine. We have to keep the outside down and engaged in the soil in order to plant. Another thing, you notice this machine is so big that there's no row marker. The row marker costs more than it is to have RTK guidance. So the row markers, being metal, cost more than the purchase of RTK guidance on the machine. So here's a good example of where technology is cheaper than purchasing the standard option on the planter. Lastly, of interest, you see a very large 9R or 9000 series tractor pulling this planter. Do you think you need that much horsepower? No. The reason we have to put a large 9000 series tractor on this planter is because of the hitch weight of the planter. The tractor itself has to support the weight of the planter when it's picked up. It's not the horsepower. So very interesting transition of normal management of machinery. So we're going to show a movie here of Carrie and Angela Knuth. This is their sons, 13 and 17 years old, planting corn at their farm. The two boys planted nearly 40% of their corn in 2013 because, again, wet spring, a lot of activities, okay? And all the boys have to do is turn the planter. Once it's turned, it's put down, they hit the buttons, and you'll see about 3 displays in that planter. So that's where we're at with technology. The nice thing about the technology on that planter is it's scalable. I can take the same technology and put it on a smaller planter, okay, and take that benefit or put that benefit on smaller farms. But the key to that whole system, that planter is very complex, is technology. How do you take a 37 meter wide machine and drive it straight? I don't think there's a person in this room that can keep it straight over a 10 or 12 hour period. Just too wide. And so we have to have technology. We also have to have technology that constantly gives us feedback about the quality or the performance of that planter. So we have row by row feedback. Okay, you see downstairs, you can see this on the John Deere 2630 display. See it on the precision planting display. But essentially, I know if every row is planting the correct population, or in the case of row 3, it's overpopulation, so I need to do something. Or in row 2's example, it's underpopulated. I can get out of the cab and fix that now. Again, spending $125 an acre, I think the technology well pays for itself to ensure that the corn is being placed out in the field properly. So we have guidance, we have this feedback to the operator about what's being planted. That's a requirement today in most cases for these large machines. Take sprayers, okay, agriculture sprayers. Basically, I can purchase anywhere from 37 to 40 meter sprayers. If any of you were at the Farm Progress show a couple weeks ago, you could have bought a 45 meter sprayer. Again, very wide sprayer. So what do we see? And we see this here. Gentlemen at Jocto, you have this technology. It's basically because of the width of the sprayer, that puts that sprayer in a disadvantage for things when I go into a turn. Okay? When a large sprayer goes into a turn, and I'll show you a picture next, we over-apply on the inside and under-apply on the outside because the boom's going so fast. So in order to compensate, we basically see about 3 companies in the U.S. today offering turn compensation on large sprayers or nozzle by nozzle control. Okay, so that's technology which is addressing application issues because of the size of the machinery. Again, this is scalable, meaning I can put it on smaller machinery and take advantage of it. Here's a map. I'll present some data just to tell you, if you're not using turn compensation, okay, this is about a 36 meter sprayer. I did not do the conversion, but operating about 18 miles an hour. 18 miles an hour, that's pretty fast. Here's a field, okay, and what you see is the green represents about 10 gallons per acre. That's what we put into the display. We want to apply 10 gallons per acre of product. not very much green there. Okay? There's a lot of over-application. Okay? In fact, we did this in 3 fields and found out in all 3 fields, basically this is the off-rate error. In the U.S., if we're within 10% of the target, we're within acceptable performance. But look, this is minus 10% to plus 10%, and we were only about 28 to 42% of the time within the acceptable range of application. Is that a problem? So most of the time you'll see we were under applying versus over applying. And if you have not heard that we have a specific issue that Dr. Stafford pointed out in the United States called weed resistance. Any idea why weed resistance might be occurring? Because under application of products in some areas of the field can be a big concern. This issue right here, I will tell you, is an unknown issue. We've published about 3 papers, which I would be happy to pass along about some of these issues. One thing about is about driver habits. And I'm not familiar with Brazilian sprayers, but if I'm a driver that likes to really hit it and go like this, it takes a while for the pump to get caught up. Versus if I'm an operator that does nice, easy controls, those 2 scenarios will generate different performance in the field. Someone that does this versus someone that does this. Okay? There is a time for the pump to respond. So that pump's turning, and when I speed the sprayer up, it's got to speed up. The other issue, which we've documented in about 4 or 5 papers, is the use of automatic section control. Okay? I'm not talking nozzle to nozzle, I'm talking section control. If I turn a section off, immediately what occurs on the other booms that are on? Pressure goes up. Again, how long does that take for that pressure to come back down? Or did it start and I'm turning nozzles on, it takes a while for the pressure to increase. And so all of a sudden, we've had most of our U.S. companies address that concern, but for about a 3 or 4 year period, we had issues with pressure spikes or increases in pressures and pressures dropping out, causing these issues right here. So I think if I did this study again, this number would probably go back up into the 80 percentile in most cases. We would probably double our ability to stay within this because of advances in technology. Talk a little bit about fertilizer. I know Professor Mullen has spent some time in this. Here's a very common granular or dry fertilizer applicator in the U.S. This is becoming more common for a couple reasons. We want higher clearance so we can go into corn at V6 to V8 and apply urea. Okay, late season application. But there's one issue that has occurred in the last 10 years. We've gone from about a 15 meter, maybe 20 meter application width up to 21 to 31, and now we have some folks trying to apply at 37 meters, okay? And do that with variable rate. So we're changing the rate. But the question has become, because a lot of times in the U.S. we put 2 to 3 products in the bin. So we make a blended fertilizer. When we try and throw a blended fertilizer 31 or 37 meters, what do we think occurs? This issue right here. One of the advantages of using drones or UAVs or remote sense imagery is now this issue is becoming more apparent, and we're seeing, I get a lot more calls on this issue right here. And this is totally due, you can see the lines, okay, off the NDVI map, where we had uniform application of fertilizer to corn in the spring. This is taken about V8, so corn's getting pretty tall, and it's showing varying biomass, or in this case, NDVI, like you could say, health as well, okay? Is this a problem? Yes. Again, I'm spending quite a bit of money to apply fertilizer, okay, and I'm getting this type of result. So this is an issue of throwing fertilizer a lot wider. We're throwing it in blended fertilizers, and we're seeing segregation in the United States. I would comment that the folks in Europe are much more fertilizer applicators than we are in the U.S. And we continue to work with companies to try and progress and change the design of material onto the spinners in order to correct this issue, but it's going to take some time. But this is an issue that's at least 4 states, 4 U.S. states I've dealt with here recently. Here's a picture. I'll show you 2 things. This is basically urea, potash, DAP, okay, is a common phosphorus. You'll notice the DAP is the dark brown. You notice it's coming out here. You don't see much pink, which is the potash in our case, but the pink tends to be here again. This is just throwing pans out. The center of the truck is about right here. And so we see segregation. And the second thing I'll point out to you is poor uniformity. We see peaks out here. Again, this is a calibrated fertilizer applicator, or at least that's what they told me. So this is the type of concern I have and what we're trying to work on to deal with precision agriculture and fertilizer application. Here's our big focus. We're going to turn our attention to some things that we're trying to promote in the United States or look at. The gentleman Monday talked about RTK, or the communication. I will tell you in the U.S., the majority of our communication is cellular or mobile based, okay? So to give you the level of this, 100%, well, not quite, but a majority, 90+% of the tractors, harvesters, and now sprayers in the United States, coming from the 3 main manufacturers, have modems integrated into them. Okay, those modems use a cellular connection. And basically, this is an example from AGCO they allowed me to use. And we're looking at machine to machine, so we can share AV lines. Okay, so we can share those guidance lines. We have multiple machines operating in the field. We can share coverage maps in real time. The other thing that I mentioned earlier is getting the data off of the machine back into the field office, so I can come home at night and not have to use one of these to transfer data. My third trivia comment for you is about 80% of the data generated in the United States, 80% of the data still is on the machines themselves today. A lot of times you will get into a harvester or a sprayer and the data card is full, being rewritten over. So the problem of getting data or building big data is getting the data off the machine. And so 80% of the data today still is on the machines themselves. So we're building all this connectivity in the United States. Our 3 main manufacturers are spending a lot of money of putting modems. Today, whether I'm a Droid or on an iOS system, most of my companies, I can look at my machine and I can look at my maps on my mobile device today. So that can go from my smartphone, or I can pull up about 3 programs today and show you my machines working today on different platforms. But I can see that machine and I can see what it's doing. And so we have a lot of new apps being built in agriculture to help farmers, to help consultants. So we're seeing a lot of these telematic and wireless. Again, the majority of that is just to get the machine back to the office so it can be in a usable form. So with that, I wanted to talk a little bit. We talk a lot in the U.S. It sounds like you talk a lot here about fertilizer. That's kind of where we're doing grid or zone fertilizer application. I'll give you one example or a couple examples today of where we're at in the United States and beyond. What are we doing next? The first thing is one of the biggest topics in the United States is variable rate seeding of corn. The gentleman yesterday referenced that as well here. But how do I generate this map? How do I generate those zones? Okay. And then go out and deploy or implement that strategy. I will tell you only about 10 to 15% of the farmers today are actually doing variable rate seeding, changing population on the go today in the U.S. Somewhere between 10 and 15%. But over 80% of our planters are being sold with hydraulic drives. And so we have a lot of interest, a lot of questions from our farmers about doing this. You guys can talk to me later about this, but I will tell you two big concerns is quality. I want to say that again. Quality yield maps. I've got to have at least 3 years of yield maps in most cases to build out or to build this management zone. And again, I think the farmer yesterday alluded to having multiple years in order to establish zones. So minimum 3 years. And then the other thing is, and I'm not going to talk about this today, is quality as planted data. Because we have to evaluate whether it's actually working or not. Or what do I need to change next year to improve variable rate seeding? So here's our results. Okay, I put them in percentage versus tons per hectare. But we've seen about a 5% increase in yield using variable rate seeding. Let me tell you, it took us about 6 to 8 years with most of our farmers to get to that. Year one wasn't 5%. Year one was a lot of frustration or being upset because things weren't working properly. But we've seen about a 5%. However, I don't know if this will be the same thing as here. The two big messages we learned is there may be some fields that variable rate seeding just does not work. Okay, and sometimes those are fields that are next to each other. So we do variable rate in one field and basically fixed or uniform rate in another field. In some fields, we have seen as high as 10 to 15%. Is that significant? Yes. Okay. And so that's a pretty big gain in some fields. A lot of people, a lot of our farmers say, well, what do I save? Where's my savings? There is no savings in our cases. We have not found any seed savings. We've only seen yield gains. So it's more of an investment, a better investment of the seed to the yield zones. Okay? Again, it's more field by field in terms of how we see the results coming out. Today we see companies, this is Monsanto, this is DuPont Pioneer, basically helping farmers generate that. Farmers will pay sometimes somewhere around $10 to $15 an acre to use that service to generate those maps. So a pretty significant. But I always say, and I want to highlight this, you got to have the right technology, and you have to be, as a farmer, prepared to go in and do variable rate seeding. Just because you purchased a planter that has a hydraulic drive, and you call John to say, I want to do variable rate seeding, I want to ask you a lot of questions before we even start down that road. Because you have to have the right technology. Do you have someone that's local to help you talk about where and how much, so they know local hybrids, they know local culture, okay? Has the farmer done anything with data management, or is all the data still on the machines? If the data is still on the machine, they're probably not ready for variable rate seeding because they have to be engaged in the process. And then finally, is that farmer or consultant set up to evaluate success or possibly failure? Can they evaluate whether it was successful or not? That becomes a harder because, again, it goes back to time. Does someone have the time to evaluate all this? So, a lot of interest, but we also have a lot of farmers in the U.S. that are not ready to go to variable rate seeding because they're just still using guidance or section control. They got to get to where data is involved, where they are engaged in the process. Today, if you have not read multi-hybrid planting, I would say as a scientist, I'm more excited about multi-hybrid planting than I am about variable rate seeding. Okay? Our first multi-hybrid planter was about 3 years ago. Bex Hybrids, which sells seed out of Indiana, worked with Kinsey, a planter manufacturer, and Raven Industries, got involved, and basically this year, being the third year, built the first commercially available, so it can be available to farmers, multi-hybrid planter. In this case, they're just basically loading 2 different hybrids on a central filled system. So one hybrid in one box, the other hybrid in another box, okay? And switching hybrids. So, a lot of excitement. Here's an example from precision planting in the U.S. So precision planting in Kinsey basically have, rather than 1 meter on each row, there's 2 meters put back to back. One spins one way and the other spins the other. You just switch back and forth between those, okay? So that's what each box, you got 2 meters. Both of the systems are electric drives, okay? So each row is its own planter because you have an electric drive now, okay? So it's an integrated dual electric drive meters. This is data fresh that I got from some agronomists. If my conversions are right, basically it's about 1/2 to 0.6 tons per hectare advantage. Okay, converting that to U.S. dollars, that's about a $22 per hectare advantage today. So again, something to consider, and what they tell me, and I have not done the full economic analysis, it pays for the planter and will help you into the future. So this is a lot of interest. To tell you how big this is, Kinsey, I forget exactly how many they made. Kinsey made so many planters and sold them through Bex, and sold every multi-hybrid planter for the season of 2015. That's how excited the farmers in the U.S. They've sold every Kinsey multi-hybrid planter in the U.S. Some things that we're working on. What's next? We talk about active downforce. Okay. What I would say modulated downforce. I'm going to show you some data from our studies that will suggest that we not only do we need to control downforce. In this example, there's actually an airbag pushing down on that planter unit. We think hydraulics would be better from a reaction perspective. Quick, but we're also think that you need to adjust seeding depth on the go. And so we're heavily involved in research that's looking at adjusting seeding depth and adjusting down pressure. Again, we want to place that seed about 5 centimeters in most cases with no compaction. So our results suggest, you can read that yourself, but there's an interaction between downforce and the depth at which it's placed. So we think both of them have to be adjusted on the go. Our vision is that basically a tractor operator would get in the tractor, we would have a soil sensor on the planter, we would know the soil texture, so between the moisture and the texture, the planter adjusts itself going across the field. That's what we're working on our research. So, of interest, you can see we went out in 2 fields and looked at the actual planting depth versus the target planting depth. And you can see we were well off in those 2 fields. So again, suggesting we need to do some research to better place that seed in this case corn, out there. This is last week. Yes, this was taken from a drone, but you can see treatments out there. I've not got my yield data yet, but you can see where too much downforce affects emergence and ultimately affects yield. So that's a visual indication. If I come back next year, I can actually have yield data to support that. We're doing this in corn and cotton. Finally, we'll talk a little bit about this concept. This has been going on for about 3 or 4 years. How about the orientation of the corn seed? Okay, this is work primarily coming out of Oklahoma State University. If I orient the seed a certain way, the corn plant opens up like this, right? I can control the leaf structure. Okay, and so we're working on technology, or they working on the technology. So I can control the leaf structure. I can maximize the leaf area index that was discussed yesterday and increase yield. That's the concept. So orientation, okay, I can control leaf structure, increase light inception, I can improve emergence. A big thing in the U.S. is emergence. We want all plants to come up at the same time. I can begin to control that because you can see here, you're getting the embryo placed differently. They're going to come up at different times. What we're looking at, we're trying to develop technology to do now is to put nitrogen at each plant, deliver nitrogen at each plant. So that's kind of the future, but that's all deals with planting. Finally, some things that I'll just throw out to consider. I'm not promoting this today, but we're seeing advantages in yield is different types of practices. So strip intercropping. In this case in the U.S., you would have a strip of corn, a strip of soybeans, corn, soybeans. Again, maximizing profit on a per acre and maximizing yield on a per acre basis. These are the type of management practices that we think in the future will provide not only yield advantages, but soil health advantages to push us into the future. But it's the precision ag that enables this ability to not only implement, but to evaluate these systems. Then finally, UAVs. Got to talk about UAVs. Everyone's excited about UAVs. We're using a lot of multispectral images. At Ohio State, we have the Air Force, the U.S. Air Force. We have private companies that consult with the Air Force involved in our research. And we're basically getting data through UAVs down to less than 2 centimeter pixels. Less than 2 centimeter pixels. And so we're using things that were discussed yesterday in Dr. Gerber's NDVI, RGB or visible, and we're also looking at some LiDAR data. But at 2 or 1.7 by 1.7 pixels, look at what I can start to see out there in the field. Number one, this is a management issue. Did not get that planted properly. Can I change that next year? Yes. I might have not known about that if I did not see it at this point. So I see things that I've never seen before, first of all, with some of this. Some other issues. This is soybeans, okay? This is corn over here. Any idea what this is? Herbicide issue. Over application of herbicide. Yield loss. Can I fix that next year? Yes. By documenting it, I can tell me how many acres of soybeans basically got over applied to, and I can make a change and not allow this to happen next year. Over here, it's a little hard to see, but you can see the lack of nitrogen here. Okay? Guess what? Our applicator came in, His first pass was down this way, and guess it took a little while to get the nitrogen coming out. Can I make a change on that next year? Absolutely. So again, I can document management issues, and I can begin NDVI for the in-season application of nitrogen. I think there's a lot of opportunity that we have found. Some other things that we're doing because of the resolution, we can count corn plants about V2, V3 at around 98% confidence. Let me say that again. I can count every corn plant out in the field at about a 98% confidence. How many of you have gone out and done stand counts? Count plants. It takes hours, no more. I can do it with the UAV. The other thing is I can look at the leaf orientation of the plant. Not only do I know where the plant is, I know the orientation of the corn plant with this type of data. And then the other thing that's on the horizon or just going to be coming, I can detect the variety, the corn variety out in the field. Now, as a farmer, that might not be of interest to you. But do you think companies that sell seeds might want to know the varieties? I will tell you, in the U.S., there is no law that prohibits someone to fly a UAV over their property. So as a company, I can go fly and figure out where all my varieties are. So just getting you to think future about some of this. We're also spending a lot of time with the LiDAR data, basically reconstructing virtually the cornfield back in a computer. But we're also looking at, I was not able, and I'm not allowed to show you images, but basically I can look and reconstruct the corn leaf. Why is that important? Because when I look at the corn leaf and we look at issues like lesions or where issues begin on the edge of the leaf, I can see that and I can go out and make a spray application before that issue basically becomes widespread. Those are the kinds of things that we're using UAVs for today. Wearable technologies, a lot of discussions. I'll just say here the Google Glass is exciting for dealerships as they work on machines and need an expert to call in. We're also looking at them from a scouting or going out and looking at crops. I can take a GPS location, I can take a picture, but I still have both of my hands available to work. Okay? So these are some of the wearable technologies. Capture audible, so I can speak and capture that, but I can also catch the visible aspect of the crop out in the field. So I'm going to leave you with this, and we'll be done. You know, whether I travel to Brazil or Europe or New Zealand, at least recently in Australia, and talk to folks like you or people like you, you know, we're all in this as an ag industry. We are tasked with the responsibility to grow more with less. That's our task. Okay, it's the thing is how do we get there? Farmers, we want farmers to stay in business. Okay, because we all want to continue to do research that we love. So we have to retain profitability, and I understand why some technologies are purchased and others aren't. But we've got to focus on the farmer and their profitability through this process. We are today, at least in the U.S. and most other countries, are very accountable for the nutrients and water we apply. If you're not today, you will be tomorrow. Water is extremely important to life, but it's also extremely important to grow crops. We have to be accountable for the nutrients and water applied. And ultimately, we have to meet the yield goals at 50 to 70%. And I'll say it again, I'm a true believer, based on our calculations, that 30% of that increase is on your shoulders here today. About how you take technology and data and generate information to push your farm to the next level. I just gave some very small examples, but we enjoy talking about nitrogen and other things. But when I think about this is the future, and these are the three things that we have to focus on to keep people in business. We have to account for the nitrogen, phosphorus applied, the pesticides applied, and the water applied to meet that yield goal. And precision ag is going to be a big part of that now and into the future. And hopefully that not only challenges you as it is, but I look forward to coming back and showing some more results of the research that we're doing that I think that would be very applicable or you can use here in Brazil. So I want to thank you. If you're interested, here's my email address. Again, I want to thank you for the committee, Professor Molin, for inviting me today to be here. Thank you.
Ok, pessoal, acho que nós tivemos uma apresentação brilhante, né? Acho que foi excelente a visão que o Dr. Fulton nos passou, né? De toda a tecnologia e tudo que a agricultura de precisão pode oferecer para a nossa agricultura, né? Então, nós vamos começar a sessão de perguntas. Por favor, vão passando as perguntas aqui para a mesa, para a gente organizar. Antes de passar propriamente as perguntas, nós queríamos dar um recado que vocês estarão recebendo aqui na saída 2 formulários. Porque nós vamos, após essa apresentação aqui, a gente vai ter um coffee break. Quando vocês estiverem entrando, né, vocês receberão 2 formulários, né, e a gente pediria que todos preenchessem esse formulário. São avaliações a respeito do evento, né, e é muito importante para a gente ter esse feedback de vocês. Então, acho que nós já estamos com um bom número de perguntas e a gente vai tentar passar. Tem um em inglês. Tá, tem uma pergunta do Michel, ele é da Exactos, no Paraguai, e ele pergunta o seguinte: conforme comentado, gostaria de saber como as empresas estão vendo esta integração de gestão, visto que nossa realidade existem N fabricantes, diferentes fabricantes. Como vai ser a comunicação dessas máquinas? Ele está... Deixa eu tentar ver se eu... Ele está questionando a questão de... a questão de ter diferentes fabricantes de máquinas e a comunicação de todo esse sistema, como foi mostrado ali, né? Por exemplo, a oficina da fazenda recebendo informações das várias máquinas, como é que isso pode ser integrado?
First, that's an excellent question and a continued concern for many people, especially those that run different type of machinery on their farm, or different what we call colors. So if it's green, red, or blue. My comment to that is that there remains issues, but the positive or the benefit today is that we have continued to evolve in which data can be started to be shared between machinery companies. I'm not saying that's here today, but we have efforts here in the U.S. and in Europe looking at ways to standardize data, allowing that to be transferred more easily between manufacturers. One group in particular in the U.S. called Ag Gateway. I will tell you, every equipment manufacturer or technology manufacturer is a participant. You can look that up, Ag Gateway, and are working towards the idea of sharing data between different company machines. I will remind everyone when we talk about Canon and ISOBUS 11783, it took 15 years from when that started in 1986 to the mid-90s before it became reality. That's a standard that now rests on all machines. So it's not going to be quick, but we see several companies in the U.S., software companies, equipment companies getting together and basically generating what we call APIs to share data between different colored machines. And so there's excitement that it'll be easier or simpler in the future, but it will not be tomorrow. It's going to take some time.
Ok, uma pergunta agora do Afonso Ribeiro, da Jumil. Jumil é um fabricante de máquinas agrícolas, né? E ele pergunta como você vê o plantio de milho em velocidades mais altas. Algumas empresas falam em até 16 km por hora ou 10 milhas por hora.
So this year in the U.S., we know John Deere and Precision Planting essentially built new meters for corn and soybeans to plant at 16 kilometers per hour. What I see in general is most of the farmers will probably, once they start to adopt those type of planters, will increase their speed, but not to 16 kilometers per hour. For my farmers in the South and in Ohio that use no-till, where it's very pumpy, they might go from 5 to 5.5 miles per hour to 6 to 6.5 miles per hour. So I see our farmers planting maybe a mile per hour faster in the future, but most cases you cannot plant 16 kilometers per hour because of the terrain and other attributes in the field that does not permit that high-speed planting.
Ok. Uma pergunta do professor Molin. Você poderia discorrer algo sobre a questão da propriedade dos dados na medida em que eles adquirem valor comercial?
Hopefully I'll answer your question. So the first step in this data process is getting it into a central location in order to use it. I think what we'll see is how will it change? The first thing I will say, data has to change coming off of ag machinery because there's a lack of accuracy in many cases. And so I will tell you at Ohio State, we are very focused on how do you certify data. So if you're a farmer and that data gets transmitted to the cloud, how do I certify that it's of a particular accuracy? So when I build information from it, that it's accurate information, that I can make a decision on. We cannot afford to deliver products, analytical products, that does not allow for proper understanding and information to make a decision. So what we have to do is improve our yield data, our certification of yield data. I think we'll learn more about that in the near future. We see 2, maybe 3 companies revising or redeveloping yield monitors to improve that. As an engineer, I'm excited that we're going to overcome some of the issues globally. But I also think that we have companies providing as applied data that need to also address issues with their as applied data. Again, I did not talk to you about that today, but I can show you maps of what went on in the field and then show you maps of what the as applied data said went on in the field, and you get 2 different answers. You get information that's basically 180 degrees apart. I would make a totally different decision based on the data. And so I think we've got to get the data into a central location and start processing it, but at some point as an industry, as global industry on data, we have to be able to certify it and clean the data, and those are 2 things that I think that we'll have to change in the data streams that I showed.
Ok, eu tenho mais 4 perguntas aqui, mas eu acho que nós estamos com o tempo esgotado, né? Senão nós vamos prejudicar todo o restante da programação. Acho que nós vamos concluir aqui, né? E mais uma vez agradecendo aí ao Dr. Fulton pela brilhante apresentação. Muito obrigado por ter estado aqui, né? E ter compartilhado todas essas ideias com a gente, né? E nós passaríamos então para entregar aqui um certificado e uma pequena lembrança do nosso evento.